Good morning, everyone. My name is Kim Foster. I'm an applications engineer here at OutBack Power, and I will be giving this presentation on lithium-ion batteries with OutBack. We'll just give a couple of other people just another minute or two, and then we'll go ahead and get started. So I'm going to put myself on mute until then, just a few more minutes. All right, good morning, everyone. Good morning again, rather. We'll go ahead and get started, and any latecomers will just have to hop in as we go along here. So again, this is lithium-ion batteries with OutBack Power, and I am Kim Foster, and one of the applications engineers here. It's just some housekeeping rules. I'm welcoming any questions you have during the presentation. You can just type them into the question box in your control panel. However, if we do start to get bogged down, we only have 60 minutes, so I may have to cut you off, and we'll just come back to them at the end if we have time for that. So please keep that in mind. All right, first off, we'll just do some battery basics. So what is a battery? It's a container of two or more cells that are electrically connected, in which chemical energy is converted into electrical energy, or electricity, and used as a source of power. So what you see here on your screen is a very basic, very generic battery cell. So not necessarily what we see in our everyday lives, but it's one part of that. So a cell, you see an anode and a cathode, otherwise known as the positive or negative electrodes, and a separator in the middle and a load that's connected to both of those. So this is the basics that make up what we actually see in our day-to-day lives. So for lead acid, this is usually called a 2-volt cell because the cell voltage for lead acid is 2 volts. It varies between chemistries, and it's just based on the potential energy, so the potential chemical energy between the two electrodes. So if it's lead oxide and lead, that ends up being about 2 volts. It's a little over. For lithium, it's about 3 volts. For nickel cadmium, it's different from that. And all that's based on the electrochemical potential between the electrodes. So if that doesn't make sense, this might. If you think about holding a ball, so a tennis ball, a baseball, whatever, about eye level, and then you drop it. Of course, it's going to fall down to the ground. So when you're holding that ball up at your eye level, that ball has the potential energy to fall to the ground. And when you release the ball, it turns into kinetic energy and it's moving towards the ground. It's similar in a battery, sort of. It's just potential chemical energy is similar to when you're holding that ball at your eye level. And then when we discharge the battery, the kinetic energy from the ball is in the battery the electrical energy that powers the load. So same idea, different concept. All right, so now what we're really here to talk about is lithium ion batteries. So what are the big differences from lead acid? I named just a few here. It was first commercialized in '91 by Sony, which is pretty different from lead since that's been around since about the late 1800s, early 1900s, and we've been using it since. And the chemistry has changed some, but not significantly. The next bullet point, metallic lithium is pretty volatile and unstable, especially when electrical current is applied, so we can't use that for our batteries. That's why it's non-metallic lithium ion, and that allows for safer construction of the battery. And that's just different from lead, since lead is basically everywhere, pretty stable material there. And then the next one, positive electrode consists of metal oxide, and negative electrode consists of some form of carbon. This is kind of more related to what we were just talking about with the cell voltages, where those potential energies are different. And you just see the difference here because the materials are different. And the next two that we're actually interested in talking about, so lithium, as compared to lead, has a pretty high upfront cost, but it does have the potential for lower overall cost. And a couple of different reasons for that. So lithium ion batteries have a higher energy density. Again, going back to what we were just talking about with the potential energy, lead acid is a 2-volt cell. So to make up a 48-volt battery, you need 24 cells. With lithium, the same mass, so the same amount of, if you put a lead battery next to a lithium battery and they were exactly the same mass or weight, then you would have higher energy output from the lithium battery than you would from the lead. So for the same, you basically get more bang for your buck with a lithium battery. They also have a lot lower self-discharge, so the reaction in the battery that causes the battery to discharge is less likely to happen in lithium batteries. So it doesn't want to happen as easily as it does in lead. So you just get a longer shelf life, which is basically the point of that. And then the really nice thing about lithium is that they have longer life. So you just get more cycles, more shelf life, what have you, just longer life overall due to a gentler molecular mechanism than the standard redox reaction or reduction and oxidation reactions that you see in lead acid batteries. Basically, the molecules in the batteries themselves, they're not beating each other up as much. So you see less fatigue over the lifetime and you get longer lifetimes because of that. And finally, lithium ion batteries all require a battery management system, some variety of that, whether it's really fancy or just a very simple one. They do all require one. Whereas lead, you can kind of think of lead as your old, not smart devices. And then lithium is more like your smart devices, so your phone and things like this. And finally, just with lead, you have many, many different varieties of lithium ion chemistries out there. So these are 6 of the most common. You see a lot of cobalt, manganese, nickel manganese, cobalt oxide, all these things. But what we'll be focusing on is the lithium iron phosphate. Most of the batteries we are compatible with right now are of this chemistry. And that's a big reason for that is because they are not always, but mostly considered drop-in lead acid replacements, which is good for us. And we'll get into that as we get into the programming section. Okay, so now we're on to OutBack equipment compatibility. And we'll first start off with our charge controllers. Any of our charge controllers are compatible with lithium except for the old MXs. So as long as you have a FlexMax FM100, 80, or 60, you're fine. It's completely compatible. And our compatible inverters, so you see here the Radian, either 80 or 48 A models, all of those are compatible. And the export models, they're all compatible as long as you have firmware version greater than the one I have here on the screen. And all of our FXR models are compatible with lithium. just be pretty specific that they do need to be Rs, so not FX or GTFX or any of these things. So the newer FXR models are all compatible. And of course, we have here on the right our skybox inverter, and there's only one version of that, so of course that one's compatible. So that was just a quick rundown of what we have that is compatible. However, if you want a better, more complete list to include the firmware versions that you need and things like this, or if you just don't remember because I spoke too fast, you can go to the application notes page on our website, and then you go down to energy storage and click on this link that I have arrowed the arrow pointing to here, deploying OutBack equipment with lithium ion batteries. It's not very specific. We'll actually get a little more specific in this webinar, but this document has, one, the list of all the things that are compatible and are not compatible. And it also just gives you some general guidelines, some very basics of how to integrate lithium batteries with OutBack equipment. So again, it's very basic. It's not really meant to take the place of good knowledge from the battery manufacturer or an integration guide or things like this. It's just meant to kind of guide you down the path that you need to start on to find a good integration between your batteries and our equipment. Okay, so now we'll get into the real meat and potatoes of this. Before this was pretty much all introduction. So the first thing we'll do is actually take a poll just out of curiosity to see how many of you have installed OutBack equipment before. So I'll give you just, we'll call it 30 seconds, 30 to 45 seconds. Okay, so it looks like most people have voted. So I'm going to close the poll, and now we should be able to share the results. And it looks like it's a pretty even spread from what I'm seeing. About a third of everybody has done either one of the categories. So for all the one or less people out there, or really 5 or less, feel free to ask any questions. I know there's a lot here that can be confusing, and the mate for sure is sometimes hard to navigate, but we do have a lot of resources, and I'll be showing those to you for better and easier navigation of the mate. And for all of those who have installed more than 5 OutBack systems, that's great. Thank you very much. And if you have anything to add or you have a specific question, maybe hang on to that until the end, unless it's very pertinent. And then we'll give the beginners maybe a little more time to ask questions. Okay, great. That was great participation. Thank you. All right, so our first example. We are going to be using the Simplify battery, the Phi 3.5. And the first thing we need to do is, oops, sorry, forgot to hide the results there. So you all should be able to see my screen again. So information you need from the battery manufacturer. This is pretty much the most important part of what you need to be able to figure out how to program the inverter and the charge controllers correctly. If convenient, for example, if we did not work with Simplify and we didn't have an application note, then we could not help you. You would need to go to the battery manufacturer and get this information because we don't have it. So if you have some obscure battery out there that we don't work with or we don't know about and we haven't tested with, then you'll definitely need to go and get this information for yourself. So one quick thing, we're going to take another quick poll before we get started too far. just to see how many people really understand what's going on these spec sheets and in these manuals. So this question, what is meant by the C/2 rate? And again, we'll just give it about 45 seconds for everybody to answer. And if you don't know, it's fine. We're going to go over it. Okay, so it looks like about 70% of everyone has voted, and I'll just give the other 30% of you a nice little ditty I learned in the Navy. 50, 50, 90. So there's only two questions, right? Or two answers. 50% you'll get it right, 50% you'll get it wrong, but 90% you're probably going to be wrong. But that's totally okay because we're going to go over it whether or not. Okay, so that might have not been as motivating to you as it was to me in the Navy. In any case, most of you got this right. Very good. So C/2 is half as fast as the 1C rate, or otherwise just known as C rate. We typically don't see the 1 in front of that. So what that means, C rate, the rate or current, you can think about it that way, since an amp, so an ampere, is really coulombs per second. Ooh, I'm sorry, I forgot to close that. There we go. Now you can see the results. Sorry about that. So again, C rate is the rate or current in this case, at which a battery will be fully discharged in 1 hour. So for this example here, one battery is 69 amp hours, a 48 volt variety. You can see that at the kind of right top portion of the screen. So 1/2 times the 1C rate, so 1C would be 69, and 1/2 times that would be 34 amps. So hopefully that makes sense to everybody. Okay, so that was just a little question to get your brain going in the morning and to help us understand what we're looking at. And finally, the specifications that I have circled here are going to be useful for us, directly applicable to programming the inverter or charge controller. However, I do want to point out that all of this information is pertinent to your installation. So we'll just pick on operating temperature, because for lithium, that's a really big deal. For lead, it's a moderate issue. But for lithium, it's pretty important to note that operating temperature, you want to make sure your installation environment is going to meet those specifications. And that's just one example of, we don't program the operating temperature into the inverter, but it is still very important. And then just take a quick note of the ones that I have circled. So amp hours, that is going to go into our state of charge algorithm, and it's also going to go into, again, our charge and discharge rate. Max continuous charge current, 34 amps. Just make sure that matches up with the other one, C/2. So 69 divided by 2 is about 34 if we edge on the side of caution. Operating efficiency, that's also known as our charge factor in the FlexNet DC lingo. Depth of discharge, that's just something for us to note. Again, for Skybox, that's where we'll use that. And then again, at the very bottom, absorb or high cutoff voltage and recharge low cutoff voltage. So those are all things we need. And information we need for the inverter charger is pretty slim, actually. So nominal battery voltage range, So you should probably know that your inverter is a 48 volt inverter or a 24 volt inverter, but that's not that hard. We should all know that. Programming manual, if it exists, just to help you navigate, make it a little easier on yourself. Minimum recommended battery size, if that's applicable. So for the Radian, 1 Simplify 5 Phi 3.5 is clearly not going to be enough. We have a 34 amp discharge limit, and the Radian can output 8,000 kilowatts if you're talking about an 8048. So clearly we're going to have to size that appropriately. And lastly, an integration guide if it is available. We'll go over those for OutBack, and many of our battery manufacturers also have integration guides for different inverters. So if you can find that either on our website or on their website, that would be great. Okay, so now we're going to get into the real programming of both the Mate 3S and the Skybox. So we'll try to go over them side by side. If you do have any questions, feel free to note those in the question box. And for those of you who are somewhat new to OutBack, 5 or less installations, this is a really handy resource. When I was new, I pulled this thing out all the time, and I still do. It's called the menu map for the Mate 3S. It doesn't show you everything that's under these menus, but it does show you how to navigate to them. And you can pull this from our website under the product documentation for the Mate 3S. But as you can see, it just tells you main menu settings, where you would find, say, the battery charging. That would be in the green row about 6 down. So hopefully that's helpful to everybody. And it's really best if you print it on 11 by 17 and in color. I found that just makes it much easier to see. Okay, so first thing we're going to do, charging parameters. We'll start on the left with the Mate 3S. Again, you can find this menu under the menu map, and so I don't have to show you how to navigate to all of those. So absorb voltage, we pull that directly from the battery spec sheet. So I'm not going to go back to it, but it was there. We pointed it out. And the time. So time for lithium it varies based on your battery, unfortunately. So for Simplify, we have worked with them, and they recommend a 6-minute limit. So that's what we have. The Mate 3S only goes up in 6-minute increments, or 1/10 of an hour. I find it to be a little easier to think in 6-minute intervals since it's a little bit smaller. So we have absorb voltage 56 and time 0.1 hours, which again is 6 minutes. Float voltage we have at 55.2 and time at 0. So we don't want to float lithium batteries like we do with lead acid batteries. They don't need it. Once they hit their absorbed voltage, they are mostly full. So the float voltage is somewhat irrelevant in this case. Just make sure it's lower than the absorbed voltage. And again, the time is 0. So that essentially disables this function. And refloat voltage, 54, rebulk voltage, 51. We'll either pull those from the integration guides or the spec sheets. And if neither of those exists, if neither of those exist, if you just you'll just need recommendations from the battery manufacturer. That would be your best bet. And then switching gears to Skybox, we have our battery charge settings. So our programming guide is coming soon. I promise it should be out soon. However, for the moment, all of these settings, except for a few that I'll point out, can be found under the battery tile. So you just hit the tile, hit edit, and hit configure, then edit, and you'll be able to change all of these settings. So this is your first page from our battery charge settings, and you'll see it says just what it says there, battery charge settings. Absorb time, absorb charge, we want that to be timed. Your other options are disabled here, timed or disabled, And if you disable absorb, a word of caution, you will never charge your batteries. They will not go into a charge cycle. So we always want that to be timed. And again, absorb voltage 56, pull that straight from the spec sheet, and the maximum absorb time, I have 15 minutes here, which is a little higher, but that's based on what I've seen, and this is a test setup. So all the way on the right, float, those options are timed, continuous, or disabled. So here, because we don't like to float lithium batteries, we're going to disable it. Float voltage can then remain the same, remain at whatever the default is, as well as the float time. So once you hit disabled, you can't see it here on this screen, but once you go up to the unit, those two options, so float time and float voltage, they'll get grayed out. You won't be able to change them once you hit the disabled button. Okay, so now that we've set up our absorb and float voltages, we'll go on to equalize. So equalizing lithium batteries should never happen unless you are specifically directed to do so by the manufacturer. Just don't do it. However, there is a nice redundancy that you can put into your programming. So what I've done here on both battery equalize settings, so both on the Mate 3S and on Skybox, you can see that the voltages are equal to that of the absorb voltage. So in whatever case, worst case scenario, somebody hits equalize because they are a 5-year-old child and got into the menus, it won't damage the batteries because the equalized voltage will just be the absorb voltage. So hopefully that never happens, but just in case, second set of protection, set your equalization voltage to your absorb voltage and make sure that your timing is 0. So on the Mate, it's just right next to it. And then again, on Skybox, it's also just to the right of that. Some differences between Skybox and the Mate 3S is the rebulk and the refloat voltage appear here with the equalized voltage for Skybox, and we saw them on the earlier screen. So you can see refloat and rebulk on the same screen as the absorb and float voltages with the Mate 3S. So just a few things to note, but they're not terribly different. Okay, so we've done our charging parameters, and now we're going to go on to our protection parameters. So again, starting with the Mate 3S, this is not updated in our documentation just yet, but it's in the works. So low battery and high battery. This is a new feature with the Mate 3S. We now have cutout delay time. So whereas previously it was an automatic 5-minute wait, and you had to use the FNDC relay in order to catch the dropout voltages with lithium, now you can set your own delay in the Mate. It makes it a lot easier to set up. So low battery, cutout voltage 49.6. That's taken from the spec sheet or the integration guide or both. Cut-in voltage is just about a volt or two higher than that. Something I usually set mine equal to the rebulk, which is pretty close to what it should be. And then cutout delay is kind of personal preference. We definitely set ours pretty low. So here I have it set to 10 seconds. Sometimes it's 30, but it's never higher than 30. Sometimes it's much lower. And similarly with high battery, that's just based on your spec sheet. So I'm not going to go back to it, but if you look on the Simplify sheet, it has an operating voltage window. You want to make sure you're below that. And then cut-in voltage, similar to cut-out voltage, just a volt or two below your high battery. And the same for the delay is, again, personal preference. So moving to the right on the Skybox, pretty much everything is the same here. You just have it all on one screen, vice 2. Okay, so unless there's questions, it doesn't look like it. We'll keep going. All right, so now we're going to grid charging and our max charge rate. So this is where it gets a little bit interesting. So the Mate 3S, your AC input and current limit is where we will navigate to for the charger limit, and that's in AC. So you see down here on the bottom left of the screen, charger AC limit 30 amps. So that's AC amps. You must do a conversion. So for example, let's say we have 3 Simplify Phi 3.5 batteries. So each of those batteries can be charged at the C/2 rate, which is 34 amps each. So 34 times 3, if you take out your phone calculators, is 102 amps. Excuse me. If we multiply that by a nominal 48 volts DC, then we get 4.9 kilowatts. Now, since we're in power, we can easily convert to AC amps. So we'll divide 4.9 kilowatts by 240 volts AC, assuming that we're connected to a radian, which is 240 volt input. So 4.9 kilowatts divided by 240 volts AC gives us about 20 amps AC. So in our case, we would lower this voltage, current, the AC charger limit to 20 amps from 30. So hopefully that made sense to everybody. And if not, we can always go over it again. So conversely, with Skybox, it's actually much easier. This is one of those settings that is not under the battery setting. It is actually under the grid tile. So you have to come out of the battery menu and into the grid tile. Again, configure, and then edit. And on the AC input settings, the charge limit is the number you want to change. So that is how much you are able to charge from the grid. If you want, and it's in kilowatts. So if you want 1 kilowatt, 2 kilowatt, or 6, that's what you would put in there. And then the next limit on Skybox is under the battery tile again, and that's the max charge current. So right now I have this set up to 34 amps because of the setup I have in my lab. That's the limit. So the nice thing is Skybox will obey the lower of the two limits here. So between charge limit and max charge current, which is in DC amps, it'll obey the lower of the two. So I can put whatever I want in charge limit. I can put 12 kilowatts, which is not possible with one Skybox, but for argument's sake, I can put 12 kilowatts in charge limit and still have 34 amps DC max charge current, and the Skybox will not exceed that value. It will charge up to 1.6 kilowatts from the grid. And that's what 34 amps times 48 comes out to be. So hopefully that made sense. It will obey the lower of the two limits. Okay, so now we've programmed our our inverters. Now we would move on to our charge controllers. I'm not going to rehash everything I just did because they're very similar. In the Mate 3S, you would just go to the charge controller menu and put in all the same values that we just talked about, and the screens will look very similar. And in Skybox, there's no need to program a charge controller because there isn't one. It's an all-in-one box. However, one thing to note with the charge controllers, to prioritize your solar charging, you want to set your absorbed voltage 0.4 volts lower for your inverter charger for a 48 volt system. And it would be 0.2 volts for a 24 volt. So I just have a short example here. So if you have a recommended setting at 56, your charge controller absorb setting would be 56, and then you just subtract 0.4 for that number for the inverter charger. And again, just consult the programming guide for more information, and the screens, you'll be able to see them there. But as I said, they're very similar. Okay, moving on to our battery monitor setup. So with the Mate 3S, it's pretty convenient. It's all located on one page. So we'll put in our battery amp hours. So that's just the nominal amp hours that you get from the battery manufacturer's specification sheet. So 69 for a Phi 3.5, and then times however many batteries you have in parallel for your system. Charge voltage 55.2, pulled that from our integration guide, and time 1 minute. Charge return amps 4, and charge factor, that's again, charge factor is charge efficiency that I pointed out earlier, so 98%. We'll pull most of these right from the spec sheet. And on Skybox side, as I said, there's a couple different screens because they kind of are in different spots here. So under the battery tile, one thing that's very important for Skybox, because many of our functions are based on state of charge, is to enter an accurate amp hour amount. So 67 is what I have here, because that's what I have connected. I have one older model of a Simplify connected to my Skybox right now. So it's 67 amp hours. And it's very important, again, to have that number be correct. Because as I said, most of our functions are based on state of charge, most of the battery functions. So our amp hours go here, and then our charge efficiency factor goes into the next screen, as you can see on the bottom left. Again, I put that at 98. Absorb end, I have at 2, and we talked about max charge current already. On the bottom right, these settings are pretty much very specific to Skybox, with the exception of the temperature compensation. So I'll come back to that. But first, excuse me, I'm just going to get a drink of water. Just a second. Okay, sorry about that. So back to the Skybox settings. Levelized cost of energy. That is the value that we use to evaluate which is cheaper, your battery source or your grid source. So if your grid source is set to 50 cents per kilowatt hour and your battery is set to 25 cents per kilowatt hour, the Skybox will know it should be using battery power. So that is basically your installation costs plus sorry, I was reading a question. So installation costs over cycle life and just a couple of different factors that we'll be publishing in our programming guide that is coming out soon. It's a little hard to explain verbally. It's easier to see it. The easier things, so maximum and minimum state of charge. That's when I pointed out the depth of discharge, and that's where this would come in. So 80% depth of discharge is what we're going to use for 10,000 nominal cycles. So our maximum state of charge is 100, because we always want to go back up to full. And then the lowest we ever want to go is 20. So the difference between that is 80. And again, this is what Skybox uses to determine when it should start a charge cycle, when it should stop using the battery, and so on and so forth. Okay, and the last one I want to talk about is temperature compensation slope. So this is applicable both to Skybox and the Radian FXRs, things like this. And it's very important that you don't use the remote temperature sensor with a lithium battery. Just unplug it or don't plug it in at all. And this needs to be set to 0. We don't want to overcharge or undercharge a lithium battery based on temperature. So just very important to make sure that that is set to 0 and it's not, and the remote temperature sensor is not used. Okay, so we're finally on to resources. This is just a quick screenshot again of how you can find our application notes. We have several. If you go to the energy storage section, we have one for Simplify batteries and we have one for blue ion batteries. However, shortly we are working on an application note for Discover batteries, Fortress batteries, and kilovolt batteries. So those are in the works, and we have them here in our lab. We're doing a lot of good testing and getting some good information from them. So some other resources, yeah, you'll be able to find all of those application notes under this energy storage section. So other resources that we have available, or we will shortly. So right now we have configuration files for all of our System Edge products. So I've highlighted that here with my little arrow down at the bottom of the screen. And so these go with all of our System Edge products, like I said, and we'll also have them for each battery that I just mentioned. So Simplify, Blue Ion, Discover, Fortress Kilovolt, and so on and so forth. We'll have those available on our website. So we're going to have 3 each. So we're going to have an 8048, a Radian, with 2 FM100s. So that'll be a configuration file for that, for each battery. There'll be a configuration file for each 8048 with 2 FM80s. And then finally, there'll be a configuration file or a drop-down menu option for Skybox. So we'll have 3 configuration files for each battery, and those will be available soon. And you would do the same thing that you do with the System Edge config files right now. You go to the website, you download them, and load them up to your unit. And just in case you're unsure of how to do that, especially since Skybox is so new, our resident videographer, we'll call him, he has put together some really good videos, very informative, on how to save or restore a configuration file with both the Mate 3S and the Skybox. So they're here. If you go to Watt School, so W-A-T-T, like the power version, Watt, on YouTube, his channel is there, and you can find both of these videos. Okay, so that's it as far as what I have. Hopefully you've learned something, and now feel free to ask any questions. I see one that says, please show your math units and the battery spec sheet in a side panel. I can be sure to do that. Sorry, it didn't. I would do that in the future. Well, apparently I've explained myself so well that there are no questions. But, oh, I'm sorry, I missed this one. Is there a plan to raise the battery voltage limit up past 60 volts so we can use the Skybox with flooded lead acid? You can use the Skybox with flooded lead acid right now. We're not planning on raising our nominal battery voltage anytime soon, as far as I know, but that I'm an applications engineer, not in product management, so that would probably be a question better asked of them. But as the moment, you can use flooded lead acid with Skybox. So another one, is there a way to keep from charging the battery when below 32 degrees? Not specifically, there's nothing we can program on our side right now to keep that from happening. Okay, so hopefully some of you are still around. And it looks like most of our questions are, oh, sorry, last one. Are the setting parameters the same for the Mate 3S and the Mate 3? Yes, they're very similar. If any of them are different, it would be the low battery cutout delay. That may not exist on the Mate 3, just because it's an older product and we introduced that with the Mate 3S. So if you do have questions on that, be sure to navigate to the Mate 3 programming manual, and that should be able to answer all your questions. But as far as the absorbed voltages, the timings, all of that exists on the Mate 3 as well as the Mate 3S. Okay, how do you know the capacity of the battery? So that can be taken directly from the specification sheet. So I'll go back to it. Be back here. So amp hours, this first one I have circled here on the right, that is going to be our capacity. That's what we're going to pull from. Okay, so I think I've answered all the questions that I can see. So now we will okay, I'm sorry. So what have you found that works best with the kilovolt batteries? So we haven't found anything just yet. We're still working on our testing, and then once we have the application note, we'll come out with that once we have our testing done. But the testing is barely just started, so I don't have a good answer for you right now. Why not use a temp sensor? We just don't want to we want to make sure that we're not changing our charge voltages based on temperature, because it's very easy to over or undercharge a lithium battery. So that's why we don't use the temp sensor, and because their temperature windows are much smaller, so it doesn't change so much anyways. Okay, I think I answered this one. How do you set for 80% state of charge or depth of discharge? So with the Skybox, it's easy enough to do. You set your maximum SOC if you want, if I understand your question correctly, if you want 80% state of charge to be your maximum, then you would just set your state of charge maximum to 80 and not 100. But if you're looking for 80% depth of discharge, so we're going to drain our water glass to 80% or to 20% because we've drained it by 80%, you would set your maximum to 100 and your minimum to 20. Okay, I think I've answered most of these questions. So I have one last poll for you. It should be a good one, well, good for me at least. And I appreciate your answers. I'll try to keep answering questions here if I see new ones. So is there a suggested line diagram to use Skybox for AC coupled to grid tie inverters? We don't AC couple with Skybox right now, so that's only with the Radian. But that was a good question. There's another one here. Can you configure lithium ion batteries on older VFX series inverters? No, you can't, because it doesn't, you can't disable the float voltage, which is pretty much the main thing that we're looking at. And we do have a little bit wider ranges of, for all of our voltage settings on the newer FXR inverters. So that's just why we can't use VFX inverters any longer for lithium. So another question, can we get the video for the webinar? I could not be on time. Somebody was a little bit late. So this video will be posted on our YouTube channel. You'll be able to hear everything pretty much but the questions. I think it's a little cut off, but the meat and potatoes of the presentation will be available online for you. And to answer the question about SOC voltage and the SOC graph scale, I'm not sure on that timeline. I'm sorry, I just don't know. Okay, great. Most people have answered in the poll. Thank you very much. I really appreciate your attention and your participation with these polls. It's really helpful for me and hopefully for you as well. Yeah, I hope you learned something and hope you guys have a great day. Thanks very much.